Welcome to Geography 485-585L, Internet Mapping. Module 2.2, Web-Based Mapping Clients, the Google Maps API, Part 1. This week we will be discussing what an API is, or Application Programming Interface is, and we'll be specifically talking about the Google Maps API in terms of the version that we will be working with in the class, some background information about the Google Maps API, including a discussion of key components that allow you to enable different capabilities within a Google Maps-based viewer. And then we will discuss a variety of examples that highlight some of the capabilities of the Google Maps API. So first, what is an API? API stands for Application Programming Interface, and you can see here a definition that has been taken out of the Wikipedia. But an API boils down to an interface that is published by an application or programming language that allows for other programs to communicate with that programming interface. So you could think of it as a complement to the human interfaces that we are more accustomed to working with in terms of web applications. So an application programming interface provides the machine-to-machine communication between components, in this case, on the internet. So what we're working with here is a Google Maps API that provides the ability to communicate with Google's servers that are providing a set of map services where that communication uses Google's API, and you write code in your application, in this case a web page, to request information and content from Google servers to display in your application. So the communication here is between your web browser that is running the HTML and JavaScript code that you've written and the Google servers that are generating the map images and providing back the content that goes into the map page that you're displaying in your website. So for this class, we are working with version 3.0 of Google's JavaScript API. Google also provides several other APIs, but we will be using their JavaScript API. If you'd like to learn more, you can go to Google's site and look at some of the other APIs to get information about those. In the case of the JavaScript API that we will be working with, it is freely usable for free applications. There are limitations in using this for applications that users have to pay for. It is subject to Google's terms of service, which they do have the right to change. And more recently, they've actually added to those terms of service limitations on the number of map requests that can be submitted per day by applications. And this is causing some application developers to rethink their use of Google Maps in their applications. And one of the significant changes that occurred with version 3 of their API was that applications that are communicating with Google services using the API are no longer required to have an API key, essentially a specific code that has been provided by Google to enable those applications to send requests to Google systems. If you're looking at some older documentation for the Google Maps API, you may see references to this API key. But again, the version of the API that we're working with, which is the current version, does not require this API key. But that's something that you may encounter as you're looking through online information or other published references relating to Google's API. So in terms of some key capabilities in version 3 of the JavaScript API are, number one, interactive maps that are based upon the mapping engine that Google makes available. And this is in contrast to another API that they have that allows you to embed static maps, essentially just static map images, in your web pages. There may be instances where you may want to use that static maps API instead, but in this case we're focusing on interactive maps. And one of the other major changes in version 3 of the API is that it has really been rewritten from the ground up to be optimized for both desktop and mobile platforms and applications. So they've modified the code so that it is more easily deployed onto a wider variety of client platforms. So the previous version was more usable in traditional desktop computers and web browsers on those computers, where they've modified it now so that the interactive maps that are published using the API or generated using the API can also be fairly effectively developed to display on mobile platforms such as tablet computers or mobile phones. So here we have listed a number of links to the background information that Google publishes on their various APIs, and then some more detailed reference information about the Java API in particular, in terms of the home page for the JavaScript API, an introductory page that provides some basics about using the API, and also a link to the tutorial for working with the API. These are valuable resources as you want to dig deeper into the capabilities of the Google Maps API. So as we move into now what you would be developing in terms of your mapping applications, one of the first things you have to understand is that when you are adding a Google map to your web page, what you're doing is you are creating a map object. This map object is a block of code that is written in JavaScript that is connected to an object in your document object model in your web page. And what that enables is the linking of the capabilities defined by the JavaScript to that object within the structure of your page. As we discussed last week, the distinction between structure defined using HTML and behavior defined using JavaScript, this is an example of that approach where you're creating a structural element in your page, quite often a div element, giving it a name in terms of an ID value, and then writing some JavaScript that allows you to link the code written in JavaScript to that object that you've created in your HTML page. So as you're creating this map object, there are 3 attributes of that object that you are required to define. One is the type of map object that you want to create. And this type can be of a road map, a satellite type map, a hybrid map that really shows a combination of the satellite and road map data, or a terrain style map, which is analogous to what you might think as a topographic map, though it doesn't have all of the attributes that you might see in standard topographic maps, but it provides a more visualized representation of what the terrain looks like, which is different from the imagery that is available through the satellite representation or the transportation and boundaries and other sort of cartographic features that are provided through the road map representation. So these are the 4 types of maps that you have to choose from, and you have to select one of them as the foundation for your map. You're also required to provide a latitude and longitude that defines where the map should be centered when it loads. So you can use this latitude and longitude value to essentially move the map so that it is over your particular area of interest, centered on that area of interest. And this is another attribute that is required to be provided when you're creating a new map object. Finally, you're also required to provide a zoom level, and this defines how near or far to that defined latitude and longitude from the perspective of map scale the initial map image is located. So essentially a zoom level of 0 is a global scale map, with higher values providing increasingly local views that are centered on the latitude and longitude that you provided. So Google Maps uses a set of fixed zoom levels starting at 0 and typically moving to a maximum value of 18, though the available zoom level for a particular map type is limited. So, and we'll talk about this in a little bit, there's a way for you to inquire as to the available zoom level for a particular map type that you are working with over a given area, because that also depends on the part of the world that you're working in, as the available zoom levels will vary from region to region. But you're required to define the zoom level as a part of the process of creating the map object. Also, when you're creating a map object, you have a set of controls that you can enable or disable as a part of the process of creating your map object. And those controls allow you to present to the user capabilities to control the zoom level. So users can zoom in and out, adjusting that zoom level that you set as a default for the map object when it's created. A pan control that allows them to move the visible map area north, south, east, and west. A scale control that will display the current map scale as a part of the display on the screen. A map type control that allows the user to select the map type, terrain, satellite, road map, or hybrid. And also a street view control that allows the user to enable or disable Google's Street View capability, which is essentially generated by their vehicles that they have driven through regions with a panoramic camera and providing an interactive street-level perspective for imagery at given locations in a map. These are all controls that, through the definition of your map object, you can display or not display depending on what the requirements are for your particular map. Some of these controls may also be modified in terms of defining styles for those, and we will illustrate at least one of those in the examples that I will show later. You may also, as you're creating your map object, define the locations of the controls within the map screen. So this is something over which you can exert as a designer of your map, the layout of your page and which controls will be displayed where. And then finally, you can actually develop your own controls written in JavaScript and HTML that can be defined and then attached to locations within the map. So if there's an additional capability that you want to add to the map, using essentially the API capabilities to enhance or control the map interface, you can develop custom controls that will provide that additional interaction to the user. That is a capability that, of course, requires a higher level of JavaScript programming that we will not be covering here, but that is a potential capability that you might want to look at. In addition to the base map types that we've already talked about, satellite, road map, hybrid, and terrain, there are also a number of map overlays that you can define that can be essentially superimposed upon the required base map. And this is an important thing to remember because you are required to define one of the four Google map types as essentially the base map for your map. You cannot suppress the display of the background information. But you then have an option using these overlay types to superimpose on that base map a number of additional objects that are based upon information that you would like to combine with the base map that Google provides. And this is really the capability that provides the mashup capability. And this is a term that emerged quite clearly in the release of the Google Maps API in 2005 and 6 as a way for developers to use the Google Maps interface and base maps as exactly that, the foundation for their maps where they wanted to show their own information in combination with Google's. And so we have a number of overlay types that are available to you for doing that. The first is a marker type, which is focused on the depictions of points. And you can specify the locations of those points, and you can also define the styles of those points as they are displayed using particular icons. So that is a way of displaying point location type of information. There's another overlay type of a polyline, which essentially allows you to define multiple points along a linear feature. So you could have a polyline as simple as 2 points that define a straight line, or you could have a polyline that may be defined by hundreds of points that represent, say, a bike trail, or a hiking path, or the route of a truck through a city. Those are all examples of polyline type overlays that you could potentially combine with a Google map that is defined simply by a sequence of points, where you can also define the style for the display of that point in terms of thickness, color, etc. You can also define polygon type features. And these are closed features, whether it's rectangular or a triangle or any irregular polygon that is again defined by multiple points, where Google will automatically close the polygon between the first and last coordinates that are provided as the set of points. You can also, through the Polygon Overlay type, define multiple polygons in a single polygon. So you can actually have several distinct areas, each represented by a single polygon that are a part of a multi-polygon. And you can also define holes within polygons or donuts through the specification of the design of a particular polygon feature. And like polylines, you can also then define line styles and fill styles. So you can determine the color and opacity of the fill that would be used to depict a particular polygon. There are also overlay maps that can be based upon images, and these are the ground overlay map overlay type, where you can make reference to an image file that is available over the internet, and that you can basically superimpose over the Google information. And what you do is you register those images to the map coordinate system so that they are essentially anchored to the ground in the map interface. This is a way to potentially display your own information instead of Google's as a base map, but you want to carefully look at the terms of service for the Google Maps API to make sure that your overlay is not violating their requirements for maintaining some representation of Google's content as a part of the map interface. In addition to those 4 overlay types, we also have 3 more that provide additional capabilities. One is info windows, where these are essentially content windows that can be popped up on top of the displayed map that allow you to essentially embed additional information in those information windows, where that information can be written in HTML or as a document object model element or a simple text string, where by defining that content, you can essentially allow your users to drill down for additional information, either for other overlay objects that you've added, whether they're markers, polylines, or polygons, or just at particular locations in your map where you would like to provide information. You can essentially bake that information into the system using the info window model to have that information available if the user interacts with the interface in a particular way. There are also a number of layer overlay types that provide very efficient means for linking to external data or services to be able to streamline the display of content in your Google Maps. One very popular one is the KML layer overlay type, where essentially if you have developed a KML file, which you can say build in a desktop GIS application, or you can even build one in Google Earth, if that KML file is put into a web accessible location, say in your home directory on the class server, and exposed to the internet as a web accessible file, you can create a KML layer in your map object that will allow for the display of the content of that KML file within your Google Maps application. So that's a nice way to be able to reuse geographic information that you've encoded in that KML format in a variety of places, including Google Maps. Google also has a layer type related to their fusion tables. And fusion tables for Google are essentially a way to have an online table that can contain a variety of attributes. And if those attributes relate to mappable information, so for example, if they contain street addresses that Google can understand and convert to geographic locations, or if they contain latitude and longitude information, or if they contain named attributes that Google can link to geographic locations like county names or state names, then you can actually add a fusion tables layer to your Google map where it will use the information from that fusion table to populate your map with features and associated attributes. Google also publishes a traffic layer and a traffic service. So this is something where you can essentially tap into the traffic information that Google is developing and publishing. You can add a traffic layer to be able to display current traffic information provided by Google on your map. And there's also a bicycling layer that provides current bicycle routing information within your map. And these are both data collections that are maintained by Google and are published as services that you can add as layers to your map. Finally, you can actually develop your own custom overlays where you are programmatically controlling the layers that are displayed in your system. So this is where you can use your JavaScript and HTML programming skills to define custom overlays if the available overlays that the API provides don't meet your needs. Again, this is something that is a very powerful capability that is well beyond the scope of what we will be covering in this class. Google also, through their API, publishes a number of services. And we will be talking more about services in a couple of weeks as we discuss the general concepts of services-oriented architectures. But this is an opportunity to highlight some of the services that Google publishes that you might have interest in at some point as you're thinking about applications that you might want to develop. The first is a geocoding service, where essentially their service provides both forward and reverse geocoding, where in the first instance, if you provide a sufficiently complete street address, their service will return to you the corresponding estimated latitude and longitude for that street address. A reverse geocoding capability is also provided where you can actually provide a latitude and longitude, and Google's service will return to you the nearest street address to that provided point. where there are additional options for being able to limit the geocoding and the activities to the current viewport or a particular region. So there are additional options that you can use for this geocoding process to help provide boundaries for Google's attempt to match your location with an address or vice versa. There's a second service, which is their directions service, where you can essentially provide an origin and a destination and some additional options, and you'll have returned to you directions between that origin and destination and a representation of the route in a form that you can integrate, say, into Google Maps. So this is a way to essentially use the Google Maps service as a way of doing route definition using their directions service. Google also provides an elevation service where you can provide either a single location or a path, and Google will then return to you a data object that represents the elevation for either that single location or the path. So you could think of this as a tool where you might be able to generate an elevation profile for a hiking trail, for example, or for a cycle route, where you've defined essentially the sequence of X and Y locations, latitude and longitude values for the particular path that you would like that elevation profile for. You can submit that using this service, and you will then get back the elevation data for that series of points. There's also a Street View service where you can essentially create a document object model element within your application, where you can then plug in the Google Street View content, so you can interact with a Street View service to be able to display that information in your web page. And then, as I mentioned earlier, there's a maximum zoom service where you can obtain information about the maximum available zoom level for a particular map type and area, so that you could potentially use that to modify the user interface to reflect the currently available maximum zoom for the data that are being viewed. Another capability provided by the Google Maps API relates to events. And events are a general programming concept where you link user activities or other events within the web page with chunks of JavaScript code that will be executed. So you could think of an event being triggered by, say, a user clicking on a map in a particular location, where that would trigger an event, and there is some information connected to that event in terms of where the user clicked, or where they released their button, where they pressed the mouse button. That's all information that is captured as a part of each of those events. The mouse down, the mouse up, the mouse click, which is the combination of a mouse down and mouse up. Those are all events that can be captured within the web browser, events that JavaScript code can be connected to so that those events can trigger some sort of action. And in the case of the Google Maps API, there are particular JavaScript capabilities that you can attach to events that allow you to provide a way to have a higher level of interaction or control by the user and by you, the web mapping programmer, as a part of the application. So, some examples that you might look for in terms of being able to process or handle events is changing items in the interface as the user zooms in and out on a map. So there may be interface elements that you want to show or hide depending upon the zoom level that the user selects. You may also want to have a web page that in addition to having the map object itself showing the interactive capabilities, you may have objects in your web page that are outside the map that you want to update based upon the state of the map. And you can use events to do that, to essentially create the connection between different document objects in your web page to each other. You could also potentially use events to synchronize multiple maps that might be controlled by a single master map. This is sometimes used when you might want to have a sort of control map that users actually can pan and zoom, but you might have some slave maps that the user doesn't directly interact with, but might be showing different data based on the state of the master map. These are all examples of the types of applications that you can build using the events that are supported by the API. That having been said, as I've mentioned before for some other more advanced capabilities of the API, this event programming approach is really a higher level of JavaScript than we will be working on here. We will look at one very simple event model for being able to handle info windows, but that will be the extent to which we work with events in this class. Let's now look at a series of examples that illustrate the capabilities of the Google Maps API, as we start with a very simple example and then illustrate some of the capabilities that I've just described. Here we have a basic, simple example displaying the roadmap style of map. And what I'm going to do is open this map up in its own window so you can see that this is what the roadmap style of map looks like. And if we right-click on the background, I can do View Page Source, and the approach for doing that varies from web browser to web browser. In this case, I'm using Chrome, but the right click on the background will often provide you access to be able to view the source code for the page that you're looking at. You can also often go to the menu in your browser, and within the menus, there will be an option to also view source for the page that you're working with. So here we have the entire set of HTML and JavaScript and even some styles that define that interactive map that I just showed you. So let me just walk you through the content of this page so that you can see essentially the elements that we're working with in defining this interactive map page. I'll make this a little bit bigger so it's easier to see. So as we discussed last week, we start with the HTML element that essentially wraps the entire page and all of the content of the page. We then have the head element, which is this block of HTML right here, that contains a number of key components for this page. First, we define a style for the page that really sets some background characteristics in terms of the HTML block and how it should be, in this case, how its height should be defined, the body block and how it should be displayed, including the background color for the body area of the page, the color of text, that's what this color element here is, and then the alignment of text within the page here with this text align center attribute. And then we are also defining a style for this map canvas element. And we'll talk about that in just a minute. But this is a way of attaching a style to an element within the body of the page where we will display our map. And I have just chosen to give that element an ID of map canvas. And as you hopefully remember from last week, the way to attach a style to a particular element with a given ID is with this hash ID name selector. And then you can specify the style information that should be attached to the element with that identifier. So in this case, we're defining that the map canvas element should have a width of 90% of the window size, should have a height of 80% of the window size, should have an automatically defined left margin and an automatically defined right margin. These can then be the foundation for a style that you might want to apply to your initial maps, but this is a nice way to start. What you then need to do is define the necessary JavaScript to create your map object. And that really consists of two steps. The first one is to link to the Google Maps API JavaScript code, because Google has essentially written a huge block of JavaScript that sits behind the scenes, providing all of the interactivity and the interaction with Google's servers. So when you're writing your JavaScript using the Google Maps API, you're using elements from this JavaScript code that Google has published in your definition of your map interface. But the first thing you have to do is link to Google's JavaScript code, and you do that using this script block right here, where we were saying that this is a script of type text/JavaScript. That's basically saying what language that script is in, and we're here specifying the source of that script. So we're referring to an external JavaScript file that we want to read the contents of and include the capabilities of in our web page. This is something that you're going to have to do in every web page where you're wanting to integrate a Google map. Without this, your Google map will not work. And then here we have a closing tag for the script that provides the balanced, complete block of JavaScript that brings the Google Maps API into our system. We then have a second script where we actually write our JavaScript code that defines the map object and links that map object to an element within the web page. So this is a critical part of your web page that really does the hard work of defining what the map should consist of, configuring the map object, and then linking it to the rest of your page so that the script knows where to display the map. So let's go through this step by step. We have defined here a function in JavaScript called initialize. This is a way of essentially wrapping all of our JavaScript in a block of code, a function that has a name, in this case initialize, that can be executed at the time that is appropriate when the page is being loaded. And I'll talk about that time in just a minute. Within this initialize function, we then have all of the commands that define the configuration of our map object. So the first thing I'm doing within this function is defining a variable, where in this case, this variable is being given a name classroom. So I can refer to the contents of this variable using this name classroom. And this variable contains a Google Maps latitude and longitude object that represents this coordinate pair, this latitude and longitude value. We're going to then use this variable name as a shortcut to define the center of our map object. So right now, this is just a way of connecting this Google Maps object that we're creating, this new latitude longitude object, to a shorthand name, classroom. So we're going to now create a second variable, in this case called my options, where we set our options that we want to define for a new map. So in this case, again, thinking about the required information for a Google map that I was just talking about, we're going to create a name value pair here called zoom with a value of 8. So we're defining the zoom level of the map object that should be created. We're defining the center of that map object as classroom, where again, remembering that classroom is this Google Maps latitude longitude object that represents this coordinate pair. So that's a way to have a reusable named object that represents that location in space. And we're defining an element here called map type ID that is set to this google.maps.maptypeid.roadmap. So this is defining the type of our map as roadmap. So we've now created a variable for our location. We've created a variable for the options to be used for creating the map. We're now going to create a variable called map that is a new Google Maps object. So this is actually the definition of our map object. And as a part of the creation of this map object, we basically provide two values. We provide the element that we want this map object to be connected to. So this is an element within your web page that you want to be essentially the container for this map object. And this phrase that I have selected here, document.getElementById, where you then provide the name of an element, this right here in quotes is the name of the ID of the object that we want to connect this map to. Okay? So, unless that object has already been created in your web page, you will actually get an error when this JavaScript is run. We also now have this My Options element, which is essentially this list of options that we defined right here. So this is a way of separately defining all of the options essentially as a list of name value pairs where we can just use the shorthand for those options here in our map definition. We could also, when we're defining the map, actually just include this information between the curly brackets, including the curly brackets themselves, in this line that creates this map object. But for readability and sort of maintenance of the page, it's much easier to actually define the options separately and assign them to a variable name that you can just then include in the text that you're using to define your map object. So that is the end of our function. And one thing to note here is that the entire function is defined by these opening and closing curly brackets. If you don't have those brackets matched up, you're going to get an error. And that's a common and easily made mistake when writing this code out. So we have the second script object that defines a function called initialize. As I mentioned earlier, if you try to link this map object through this phrase right here to the map canvas element, if that element has not been created yet as the page loads, you're going to get an error message. So the way we handle that is through the use of the definition of an onload event in our body. So as you remember last week, when you create your web page, you have your style and script information that you put in the head of your page, and you put your content and structural information in the body of your page. When the body has finished loading all of its content, this onload event will be triggered. We just talked about events previously. In this case, what we're doing is we're attaching a function to this onload event, where that function is this initialize function that we developed right here in the head up above. What that does is it delays the execution of that block of JavaScript until the body has finished loading, which means that it will be delayed until the div that we've assigned this ID of map canvas to, it will be delayed until that object has been created in the page so that our map object can be attached to it. So there's an important sequence that has to be followed when creating your map object or writing your JavaScript to manage that map object. Is that while you can write your JavaScript and place it in the head of your page, you can't actually execute the JavaScript that has to be attached to objects in your page, like the map canvas div, until the rest of the page has loaded. And that's why we are defining this initialize function and then executing that initialize function when the page finishes loading. You can see here that the body of the page is incredibly simple, where we basically have an h1 header and a div, where that div is given an ID that the map object will then be connected to, and that the JavaScript will then fill with the interactive map. So now that we've looked at the code behind this, let's look at the page again. And you can see that basically we have here at the top, this is that h1 header, just called sample map in this case. And then this area where the map appears is that div that was given that ID of map canvas. And that's it. The structure of the page only consists of essentially two elements, a header and a container for the map. The JavaScript is handling all of the capabilities for the interactivity of this map in terms of the ability to pan, either using the hand tool or using the pan controller up here, the ability to zoom by just clicking on the zoom control here, the ability to choose the different map types. So this is, in this case, I just chose a terrain type. Or I can choose a satellite type. I can turn the labels off and on. This is essentially the equivalent of the hybrid map type. And this is just the satellite imagery in terms of the way this particular set of controls are presented. But all of this interactivity is being handled by the JavaScript that is a part of the API that Google has provided. And we have essentially only had to provide the information necessary to define our custom part of the map, where we would like the map to start in terms of the zoom level, where it should be centered, and what object in our interface that map object should be connected to. So let's go back to our slide. As you can see here, within the slide, we have the sample code that I've just been describing here also displayed on the slide if you'd like to review it within the slide presentation itself. And that's the pattern for all of these demonstration slides that I'll be presenting here. So let's now look at the next example, so you can start to see the pattern in where you can make very basic changes to the source code to achieve different effects. This is an example of, again, a simple map that displays, in this case, the satellite information as the base map. So let's open that up in a new window again, just by clicking on this link within the slide. This is our default view of the map based upon the definition within the JavaScript for the map object. If I right-click on the background of the page and choose View Page Source, again, we can see the source code here, and I'll make this a little bit larger again. And the source code here, and I'm not going to go through it and all step by step again, I'm only going to highlight the one change that was made from the previous source code that we worked with. In this case, in the options for the map object, instead of the map type ID being road map, the map type ID is satellite. This is the only change that I needed to make to change the default map from the road map to the satellite mapping style. Other than that, everything is the same. The styles that I defined for the page and for the map canvas, the link to the JavaScript Google Maps API, the definition of the initialize function that contains the definition of our map object and the command that links that map object to our document object element named map canvas, and then the body that defines just those two simple elements, the h1 and div, that is given the ID of map canvas. So just by changing that one value in the options for the map object, we've changed our map from a road map to a satellite map, as simply as that. So if we go back to our example, again, you can see in the slide the source code that corresponds to this satellite map, and it's showing that same only single change. If we move forward to a hybrid map example, again, hopefully this pattern is becoming clear to you. This is the hybrid map, and again, as I showed you earlier, in the current Google Maps interface, that is basically a way of toggling this labels checkbox on so that the roads and labels will be displayed in combination with the satellite background. If we look at the source code for this hybrid map, we again basically have the exact same page except for this map type ID value that in this case is set to hybrid. That's the only thing that has changed in this page. Other than that, the HTML and JavaScript is exactly the same. Our styles are the same. Our script link to the Google Maps API is the same, and our body is the same. Our final example in terms of our simple map types is the terrain map style. So if we view this in its own window, you can see how this map style really highlights the variations in the terrain as opposed to the satellite type that shows, more vegetation and developed urban areas. The emphasis here is more on the shaded relief depiction of the landscape, providing a much clearer view of what the shape of the land is within the map interface. If we view source for this page, you again can see everything on the page is the same except for this map type ID that in this case has been set to terrain. Everything else is unchanged. The styles, the link to the Google Maps API, and the body area. So just by changing this simple parameter in the definition of the map object, you can fundamentally change the type of map that is being displayed. And move on to some other modifications that you can make in the configuration and what those modifications look like. In this case, we have gone back to the hybrid display type, but we have changed the zoom level. So if we view this in a new window, you can see that as opposed to the very large regional view that we started with as the default value in the previous maps, in this case, we're centered over a part of the University of New Mexico campus. And we have also chosen, as you can see, through the combination of the labels for the roads and the roads themselves and the background imagery, that we're using a hybrid map style. And you can see that again in the controller up here as we have the satellite map type chosen. We also have the checkbox for labels selected, which yields us that hybrid map type. If we view the source for this particular page, we have essentially two things that are changed from the code that we've looked at for the previous pages. The first is we've now set the zoom level to 18 for this particular map. So this is a way of setting the default zoom level for the map that will be displayed. And in this case, 18 is a very localized zoom level. And we also have set the map type ID to hybrid, providing that combined view of the satellite imagery and the labels and roads. Other than that, again, the structure and content of the page is the same. Here, what we can look at are some examples of how you can modify the interface elements themselves as they're presented to the user. So, as an alternative to the larger, more complex controls that we were viewing in the previous map examples, this is going to show some changes to the controls that are displayed to the user in an effort to simplify or streamline the user interface. So if we view this in its own window, you can see here that we have the zoom control, which has been made much smaller. So we no longer have that ruler that essentially connects the plus and minus zoom controls. This is just a small form of that. You have the different presentation of the map options here. So it's a more compact pop-down list as opposed to the side-by-side listing of the map options. And those are the key attributes that have been changed in this particular map interface. You can see we're still using the hybrid map style, and we're still at that very localized zoom level of 18 in the map that has loaded. So if we view the source code on this, you can see that we still have our style defined. We still have our required connection to the JavaScript API from Google, but we have modified the script that defines our map object with some additional options for the map object, where previously we had defined this zoom option, the center option, and the map type ID option. We now have 5 other options that we have also defined. And as you look at the documentation for the Google Maps API, you will see that there are required options, essentially these 3 that we started with. But there are also a large number of optional values that you can also provide to further define your map. In this case, we are explicitly setting some options for the zoom control. So that's what we have right here, where we have 2 options that are defined. Zoom control true, where that is basically saying display the zoom control. So regardless of what other options may be set, let's explicitly ensure that the zoom control is displayed. And then we also have zoom control options, where we are defining the style of the zoom control, in this case to the Google Maps zoom control style small. And that produces that compact zoom control that we were seeing in the map with just the plus and minus buttons on top, stacked on top of each other. We now also have, related to the map type control, an explicit setting of true for the display of that control, and also the map control options that provide additional detailed information about how that map type selector should be displayed. And in this case, we're setting the style to drop-down menu. So that's defining how that map type control should be displayed within the interface. This is essentially overriding the default display of that map type control. And finally, you may or may not have noticed in this particular map, the street view control is not displayed. If you look at the previous maps, you'll see that there's a little street view control that looks like a little stick figure over in the upper left-hand corner of the map. In this map, we have suppressed the display of the street view control by setting this option of street view control to false. So that's a way where we can both explicitly enable and disable particular elements within the user interface. So these are additional options that we have provided as a part of this My Options variable. So that essentially the content of this variable is larger, but we're still then just using that variable as we execute our standard map object creation function here. So we're creating this map object and defining its creation using this My Options list of options that we've created up above. Other than that, the rest of the structure of the page remains the same. We have this simple body that consists of a header and a div with an ID of map canvas. So with those options, we can go back to the map and understand that we turned off the street view option, which had been appearing over here in the left-hand corner with some of the other tools. We had defined and modified the display of this zoom tool, so now it only shows a simple plus and minus stacked on top of each other, where the previous map had shown a connecting sort of ruler between them that indicates visually the zoom level that is currently active. And we've modified the map type selector so that instead of that horizontally oriented selector, it's more of this drop-down style of selector. for the user to interact with. So those are some tools for being able to modify the sort of layout and background content of the page in terms of the base map types and default view characteristics for the map that you're working with. We're now going to start talking about a number of overlay types and talking about how you can define them to be able to add them to your map as additional information above and beyond the base map that Google provides. And the first overlay type that we're going to talk about is markers. So these are, again, markers of point locations within your map that you want to highlight for some reason or another for the users. So if we view this in its own window again, you can see in this map, I've created two markers. One that's approximately located near my office, and one that is located over what had been our previous classroom location before we started to develop the online course. So in this case, I have these two markers that you can see are anchored to the rest of the map, because they are defined using geographic coordinates that the map interface is able to link to the underlying base map that is being displayed. So if we view the source for this page, you can see, again, in the head area, our standard style and initial script to connect to the Google Maps API JavaScript. But we now have a larger block of content inside our initialize function where we are defining some new values. You might recall in our previous maps, we had already created this variable called classroom. And we had linked to that this latitude longitude object that defined a set of coordinates for that classroom variable. And we were using that to define how the map would be centered. What we will see now is an example of how we can reuse that variable for other purposes. We've also now defined a second variable called office that is based upon another Google Latitude Longitude object where we specify another coordinate, another latitude longitude value pair that is connected to this variable called office. We're creating our basic map options variable. In this case, this is back to our very basic settings of just the zoom set to a zoom level of 18, the center value, which is set to the classroom variable, and the map type ID of hybrid. All things that should be fairly familiar to you now. And we're creating our map object with the name of map and defining it through a connection to the map canvas and the options that we've created. So far, this is all basic stuff, very much like we've been talking about for our simple maps. But now we're going to extend the model by defining two markers. And you define the marker by doing two things. First, creating a variable that you give a name. In this case, we're calling this one classroom marker. And you create for that variable a Google Maps marker object using this function that I have highlighted here in the slide. And then you assign two values for that marker. First, a position, where in this case, we're using the position that we defined up above for the classroom. So by using essentially that classroom variable, we're referring to this Google Maps lat-long object that we created up above. So we're able to reuse that object since we attached it to a variable name. We could also directly add this google.maps.latlong coordinate function here in place of the classroom variable that we're using. But again, for readability and for maintenance and management, this is often a better way to define your markers, because you can then more easily track and manage those variables, and you can reuse them more easily. And in this case, we're also setting a title for our marker that, as you might have noticed as I hovered over those markers in the map, then become pop-up values so that you can display some simple information about those markers when the user hovers over them as a default behavior within Google Maps. Once you've created this classroom marker variable that is a marker object, the next step to actually display that marker is to attach it to a map object. And you do that here using this classroom marker, which is the variable that represents that marker object that we just created, dot set map, which is basically a capability of that marker object, where we then tell it what map object we want to link that marker object to. So in this case, we're attaching it to our map object named map. Remembering up above that when we created our map object, we created this variable called map. That's what we were referring to, because that map variable is our shorthand reference for the map object that we created. This would allow you to possibly even have multiple map objects within a single page, each of which has their own variable, their own name. In this case, again, we are attaching this classroom marker using the setMap function to connect that marker to our map object named map. Similarly, we're going to create a second marker object, in this case named office marker. We're going to create that marker object again using this new google.maps.marker function. And we're going to define for that marker object a position, where again that position in this case is using that office variable, which we defined up above as this Google Maps lat-long object that I have highlighted here, defining the latitude and longitude coordinates for that lat-long object, and defining a title for that marker as well. Those are two characteristics of that marker object that will be created, just like we had those similar characteristics for our previously created marker object, where the name of this marker object is again called office marker. Like our previous classroom marker, once we have created that marker, we have to attach it to a map object before it can be displayed. So in this case, just like our previous marker, we refer to the variable name office marker. That's essentially the pointer to our marker object. And we're executing this setMap function for that object marker, which requires us to provide the map that we want to attach that marker to. And in this case, we're attaching it to our map object named map, just like we did for the classroom marker up above. This results in what we see in the map here, where we basically have two marker objects that are anchored to our map object and displayed at the position that we defined, and as you hover over those markers, the titles are displayed. So let's now extend this with the integration of a polyline into our display. So if we open this up in a new window, you can see that we still have our two markers, but what I've now done is defined a linear path that connects those two markers. In this case, it's an approximation of the walking path between my office and the previous classroom for this class. So let's view the source for this page and make it a little larger. See that the style and initial script for the connection remain unchanged. And move right here again to the initialize function, where all the work that we've been doing thus far has been taking place. You can see that we still have this classroom variable that defines the coordinates for our classroom. We have our office variable that defines the coordinates of the office. We have this my options variable where we're defining the options for our map object. We have the creation of our map object itself using the options that we've created up above and linking that map object to our map canvas div element down in the body of our page. We have our two blocks of creation, then attachment code for the markers that we created in the last example. So here's our classroom marker code and our office marker code. So that's all stuff that we've seen previously. Now we're going to talk about the block of code that defines our path. And this process should hopefully be becoming a little bit more familiar, as it's conceptually very similar for everything we've been doing so far. So in this case, we're going to create a variable called office visit coordinates. And that variable consists of a JavaScript list of Google Maps latitude longitude objects, where you know that it's a JavaScript list by essentially these square brackets at the beginning and end of the list of comma-separated values. And our goal here is to essentially create a variable that includes the sequence of latitude longitude values that we want to use to define the path, where we are again reusing two of the points that we've created previously, our office point defined up above and our classroom point. And we are now, in this case, directly creating additional lat-long point objects or lat-long coordinate objects as a part of this list of coordinates that we want to use to define our path. So in this case, this list of coordinates that we're going to use and define for this variable consists of office, this new lat-long object that is located at one geographic location, the second new lat-long coordinate defined at another geographic location, and then finishing with the geographic location that's associated with our classroom variable. So this is just a list of points. But we can then use that list to define our polyline, which is what we're doing right here, where we're creating a variable called office path right here. And that office path variable is a Polyline Google Maps object where we set a number of characteristics for that object. In this case, we're defining the path for that polyline to the variable that we just created, that is that list of coordinates called office visit coordinates. Here we're also defining what the color of the line should be. In this case, it's basically a shade of red. The opacity of that line, which ranges from 0 to 1, where 0 is completely transparent and 1 is completely opaque. And the stroke weight of that line, which is essentially the thickness of that line. Those are all values that you can define for this polyline to control both where it is and how it should be displayed. And you can see that basically all of those options are contained within these curly brackets that define a JavaScript dictionary that consists of names and corresponding values, separated by commas. Finally, just as we did with the markers, once we've created this office path variable that represents this polyline object, we can then attach that polyline object to a map. And just as with our markers, we refer to that polyline object by name, by the variable name that we've attached it to, and use this setMap function for that object, and then specify the map that that object should be attached to. In this case, the map object that is associated with the variable named map that we created up above. And that results in the display of this polyline object here as a part of our overall map display. And as like the markers, you can see by the fact that the polyline is defined using the same coordinate system as the rest of the map, that it is anchored to the background layer, the background image. Let's now talk about the Polygon Overlay type, where you can see here that instead of the polyline, we've now defined a Polygonal Region that has both a defined boundary and a fill, where this is a closed geometric object that is defined by a series of points. So we can view this in a new window so we can see the broader context for this. And then we can view source on this to see what it looks like as we're defining this polygon object. And this should hopefully be fairly familiar to you now, as the pattern remains the same as what we've seen earlier. So as we scroll down to the initialize function, we still have defined our classroom and office variables. We've defined the options for the map. We've created our map object. We've created our classroom marker and our office marker. And what we're going to be talking about now is the code where we're defining the coordinates for our polygon, just as we defined the coordinates for our polyline, and then using those coordinates to create our polygon object. So in building our building coordinates and constructing our building coordinates variable, in this case, we are just constructing this list of coordinates, this list of Google Maps lat-long objects. And so you can see I'm creating this new variable called building coordinates and assigning it, starting with this square opening bracket, a series of these new Google Maps lat-long objects, all of which are separated by commas. you'll notice that the first and last coordinates, so this coordinate here and this coordinate here, are not the same. Though your polygon is a closed feature, Google Maps automatically will close the feature for you by connecting the first and last points to close your object, which is something you want to keep in mind as you define the series of points so that you don't end up with something odd in terms of a strange line that crosses through your polygon that does not represent sort of the shortest path between your first and last coordinates that you want to use to define the polygon. So here, we've essentially defined a series of points using this Google Maps lat-long function, and this has created this list of coordinates, this list of lat-long objects that we can then use to build our polygon object, which is what we do here with this creation of a new variable. In this case, we're calling this variable BLDG poly, where that new variable is a polygon object that we define with this google.maps.polygon string. And then we're defining the characteristics of that polygon object with this series of options that are surrounded by curly brackets for that polygon function. So here with the paths option, we're basically pointing to that building coordinates list that we created up above as the sequence of latitude, longitude locations that represent the boundary of that polygon. You can potentially provide multiple paths or multiple lists of points for this path option if you needed to create a multi-polygon, but we're only here illustrating a simple polygon for this example. Just as with the polyline, you can define a stroke color. In this case, this is again a shade of red. The stroke opacity, so this is again the opacity of the boundary line for the polygon. In this case, it's slightly transparent with an opacity of 0.8, a stroke weight of 2. So these are all, again, attributes of how the line surrounding the polygon should be displayed. And here, since this is a polygon, we have additional parameters that we can define in terms of the fill color, which is this same shade of red, but it actually looks different because we have also set the fill opacity to 0.35, which makes that fill color much more transparent. And as a result, it looks different from the same color that's being used for the surrounding line. Finally, once we have created this polygon object, just as with our previously defined polyline and markers, we have to attach that polygon to a map. And we go through the exact same process of referring to that polygon object by name, dot this setMap function, and then specifying for that function the name of the map object that we want to attach that polygon to. In this case, again, our map object that is attached to the variable called map. Nothing else has changed in the structure of this page other than essentially defining that polygon and attaching it to our map object. So if we look back here, again you can see this polygon that is defined by that series of points with the boundary of that polygon as this fairly opaque shade of red and the fill of that polygon being a lighter shade of red that is really created through its increased transparency. The actual color specification is the same, but due to the transparency, it looks lighter. Finally, let's look at the process for adding an info window to your map as a way to provide more structured or just additional information about the objects in your map. And while the info window that we will be developing is a very simple one, given the fact that you can actually have an info window that can contain just about any HTML you can develop, you can imagine how complex you could make the content of the information that is presented in an info window. So let's view this page in a new window. And in this map, I have attached an info window to this classroom marker. So if I click on this, I then get this window that displays some information about that particular object. And so what we will show here as we look at the source code for this example is how to create the info window object and then how to link it to another object in your interface to then trigger its display. So if we view source for this particular map, we can scroll down to our initialize function, and we can see all of the materials that we've already created. Again, our marker locations, our point definitions, the options for our map, the display of our markers, the creation and definition of our polygon, the linkage of that polygon to the map. That's all of this that I've highlighted here, which is the same as what we've seen previously. And what we're going to focus on here are these additional JavaScript components that define the content of our info box, create the info window object, and then link using an event listener. As we talked about events briefly earlier, this is the one instance where we're going to be using the event model to connect content to other material within our map, to basically use the event to attach the display of that info window to an object in the map interface. So let's go through this step by step. First, we're defining here the content of the info window. And the way we do that in this case is we're just writing HTML. And what we're doing here is we're basically creating a text string that is going to be connected to this class info content variable. And that text string is the definition of the HTML that we want to have displayed in that info window. So what we're defining here in this case is several lines of text that we want to have combined together into a single text string that is the content of that window. So here I'm creating a div, an HTML div, just like we've seen before, the standard HTML, that in this case I'm assigning a class of info box to, which would then provide me the ability to define a style for it later if I'd like to. I'm creating a paragraph that contains some text that I want to have displayed in the info box. And then I'm creating a closing div tag to wrap it all up within that div that I'm creating. The plus signs that I have at the end of each line here basically tells JavaScript that I want to continue this text string on the next line. That allows me to not have just one long block of quoted text, but instead I can have line breaks between the parts of text that I want to combine together to make my code more readable. The plus signs, again, just say, take this line and combine it with the content of the next line, where each of your text strings have to have quotes around them, either single or double quotes. I'm using single quotes in this instance because I also am using double quotes inside my text here to define my class name. And so since I want to use double quotes inside my div definition, I'm using single quotes to define my entire text string. This is something that you want to keep an eye out for as you're creating text strings in JavaScript or any other programming language for that matter, is how you're using quotes and making sure that you're not accidentally combining single and double quotes in ways that are going to break up your text in odd ways. So in this case, I'm using single quotes to define the text content for each of the 3 lines that I'm creating here that will ultimately produce this longer text string that starts with the opening div tag, contains this paragraph element, and then has a closing div tag. So this is just a text string that is associated with this class info content variable. I'm now going to create my info window object by assigning that to a variable called class info window. And I'm doing that by creating this new google.maps.info window object, where in this case, I'm just setting the content of that object to this class info content variable that I created up above. Again, this is a way of separating sort of the definition of that variable from the use of that variable here in the definition of our info window. We could potentially put that string content directly here in our info window object creation code, but it would make your code a little bit less readable. So again, we've defined the content outside of that, and we're just using the variable that points to that content here in the creation of our info window. And that's the only setting that we're using right now in creating that info window object. Finally, we're going to attach that info window to an object in our map so that it will automatically be displayed when the user clicks on that object. And that requires us to use the event listener support in the Google Maps API to essentially listen for a specific event and then take an action based upon that event. So in this case, we're using this google.maps.event.addListener function. And we're basically saying, use this object name as the object that we're listening for this event on. So in this case, we're using the classroom marker object, which is the marker that we have that we want to connect this to. We're saying, listen for the click event for that object. So basically, when somebody clicks on that object, where that object is here, the classroom marker object, when somebody clicks on that object, execute a JavaScript function. Where in this case, we're defining the JavaScript function using this structure here. So we're basically using an anonymous function that contains then the one command that we want to use. So the way you do that is just this function, open, close, parenthesis, and then these curly brackets that contain the actual JavaScript code that you want to execute. This is just a JavaScript syntax model for being able to define one or more JavaScript commands that you want to execute as a part of this function. In this case, what we're going to be executing is the open command for this class info window object, where again, that is the info window object that we created above that contains the text that we want to display. That info window object has an open function that then defines both where that info window should be displayed in terms of the map object where it should be displayed, and the location where that info window should be displayed, in this case at the classroom marker location. Remembering, way back at the very beginning, we defined this classroom variable with this coordinate, and we created this classroom marker as being associated with a particular position. So that information is propagating down here where we are saying, open up within the map object named map at the location of the classroom marker object, this class info window object. So this is all of the information needed to then display that info window at a particular location within a specified map. And the rest of our code here remains unchanged from what we've looked at previously. So if we look back at our map, we can again see that we have our polygon, we have our markers. If I hover over the markers, I still see the title information that has been provided. But if I click on this classroom marker object, by clicking on it, I'm triggering that click event associated with that marker. And when that click event takes place, the JavaScript that has been linked to that event is executed, where the JavaScript in this case involves the display of the info window that we created. And that info window is an info window object within our JavaScript code. So we've just provided an overview with a lot of examples of different ways to integrate content and define a Google Maps object in a web page. So hopefully this is a good foundation to combine with your reading to be able to then start experimenting with the development of your own Google Maps that are embedded in web pages that you develop. Some other issues that we need to talk about really relate to some questions and answers to those questions that typically come up at this point in the course. The first one being the use of alternative editors for the homework assignments and lab assignments, where the lab assignments so far have focused on doing editing on the classroom server using the Pico editor. That can be fairly limited, especially as you start working with more complex web pages. And this is where you can use a local editor on your own computer, whether it's Notepad or TextMate on the on your computer, or whether it's one of the more advanced editors like Notepad++ on Windows, or Coda or BBEdit, or another one of the commercial editing applications on the Macintosh, where you actually do your HTML coding on your home computer, and then you copy those files over to the classroom server. The way you can do that is use whatever editor you like on your home computer, and then you can use a program that basically can support the Secure Copy Protocol, or SCP, to move those files from your local computer to the classroom server. The two programs that are recommended for this class are WinSCP for Windows or Fugu for the Macintosh, both of which can be used to do exactly that. So I'll have a couple of short videos that demonstrate how to use each one of those applications linked from the class webpage that you may want to take a look at so that you can have a basic understanding of how you can use the workflow of local editing and then copying files over to the server for future work that you're doing for the class, as you'll probably find that easier than continuing to work in the Pico editor. regardless of how you create the content on the class server, you're still going to need to run the web update command on the class server to make sure that the permissions for the files that you've either updated or created on the server have the correct permissions so that they're available for publication over the web. And as always, if you have any additional questions, I encourage you to come into our Tuesday afternoon collaboratory, where I will be online to answer any questions that you have, and hopefully some of the other students will be there as well to chime in with their insights as well. So that concludes this class session, and